Hi everyone, so it's Coach Fred, and I'm going to be going over from the official College Board Study Guide, Practice Test 3, Math Calculator number 15. Actually, this video is going to be a little bit longer. I'm going to ask you, before we start this problem, to kind of go back. This question depends on your knowledge of surveys and data analysis. So the College Board did a great job in creating lessons for the math section of this test. So I'd like you to go back to page 224. And if you're on page 224, it looks something like this. And right down the middle, or right at the top of the page, it starts to talk about studies. So I'm going to ask you to read through all the way to the bottom of the page and then come back. And we're going to kind of discuss it as best we can on a video. And then I'm going to do the problem, okay? So again, take a second, press pause, go ahead and read that page. It's page 224 in the 2020 College Board Study Guide. And I'll be waiting for you. All right, so you took some time and you read it. And I'm going to start by just starting right here. Right here. Another primary focus of statistics is to investigate relationships between variables and to draw conclusions about cause and effect. For example, does a new type of physical therapy help people recover from knee surgery faster? That's information that physical therapists might want to know and doctors might want to know. For such a study, some people who have had knee surgery will be randomly assigned to the new therapy or to the usual therapy. The medical results of these patients can be compared. The key questions from a statistical viewpoint are, is it appropriate to generalize from the sample of patients in the study to the entire population of people who are recovering from the knee surgery? And is it appropriate to conclude that the new therapy caused any difference in the result for the two groups of patients? So these answers really do depend on random selection and random assignment. So those are two different things. So if we're going to create a study, and the study was, people were selected at random from the entire population in question, the results can be generalized to the entire population because random sampling ensures that each individual has the same chance to be selected for the sample. So it's got to be random sampling from the entire population in question. So it could be a random sample of everyone who were patients getting the surgery. Okay. Then the subjects have to be randomly assigned to the treatments, either get the treatment or don't get the treatment. So those two things have to be true. Now, at the bottom of the page, it actually kind of told you, it summarized this information in a table. Okay, so let's pretend we have subjects and they were selected at random. If they were selected at random and then randomly assigned to the treatments, then results can be generalized to the entire population and conclusions about cause and effect can be drawn, okay? Then also what could happen is they're selected at random, but they're not randomly assigned to the treatments. So you have to look for both of those conditions to be true. Otherwise, results can be generalized to the entire population, but conclusions about the cause and effect should not be drawn. So you have to know this about when you're doing a survey of some sort or you're selecting people for some type of treatment. So now we can go back to question number 15. It said, in order to determine if treatment X is successful in improving eyesight, a research study was conducted. From a large population of people with poor eyesight, 300 participants were selected at random. Okay, so we're taking a random population from the group. Half of the participants were randomly assigned to receive treatment X, and the other half did not receive treatment X. So again, it was a random assignment. The resulting data showed that participants who received treatment X had significantly improved eyesight as compared to those who did not receive treatment X. Based on the design and results of the study, which of the following is an appropriate conclusion? Okay, so let's talk about this. Both results can be generalized and cause and effect can be drawn because they were selected at random and because the subjects were randomly assigned the treatments. Okay, so that means that because those that received treatment X had significantly improved eyesight, that means we can say that treatment X is likely to improve the eyesight of people who have poor eyesight. Because remember, that population was from the population with poor eyesight. So let's go through our answers. Treatment X is likely to improve the eyesight of people who have poor eyesight. That's a true statement based on this sample. Treatment X improves eyesight better than all other available treatments. That's incorrect. Treatment X will improve the eyesight of anyone who takes it. That's not true because this population was those with poor eyesight. Treatment X will cause a substantial improvement in eyesight. That's not enough information because, again, it has to specify those who have poor eyesight because it's from the population selected. So my answer would be A. Okay, I want you to make sure that you go back to Chapter 17. Chapter 17 is a wealth of information that the College Board put a lot of time and effort into creating to help you on this test. So reading it through, trying the examples, and really understanding this piece can help you so much, especially if your school doesn't offer a lot of time to be spent on random sampling or any statistics. Just because of timing. All right, guys, hopefully that was a helpful video. Sorry it was a bit long today. Have a great day.